Hello and welcome back. So in this video, we are going to discuss about the interaction terms. So let's first understand what is the meaning of an interaction term. So let's take a simple example. So imagine you are trying to predict how well a plant will grow based on two factors, sunlight and water. You know that sunlight and water, these two are the important factors when we talk about the growing of a plant. These are the two important factors. Someone can think that, yeah, more sunlight and more water would always lead to better growth. But if if you think rationally and if you think in terms of the real scenarios, then you can understand that this is not always the case. If a plant gets too much water without enough sunlight, it might not grow well. Similarly, too much sunlight without enough water could also harm the plant. I think you are easily able to relate it because this is very practical thing that we are discussing here. So this is where the interaction terms come into play. They help us understand how the effect of one variable, like sunlight, depends on the level of another variable, like water, right? So both are dependent on each other. So wherever we see that kind of relation where one variable or one feature is dependent on the other, then we have to think of the interaction terms. We are going to discuss that when you have to think of the interaction term and when it will be really useful, right? That we will discuss ahead in the coming videos, that where the interaction terms are useful. Because these kind of scope, like there is a scope of interaction between the two variables, you can always find you can, most of the times you can find in your data set. But you need to understand that what scenario, for what purpose you are preparing your machine learning model. So if your machine learning model has the objective for that thing, like it is going to achieve an objective where the interaction between the two terms or the multiplier effect of the two terms is really important, then in that case, the interaction term will play a role here, right? So we are going to see another simple example here. So let's say we are trying to predict how much money a person spends on ice cream. We might consider two factors, temperature and income. So first of all, let's see the main effects. Main effects means the independent impact of temperature and income, right? So temperature. So we can assume here, not assumption, basically this is the real world scenario. This is not the assumption. So as the temperature increases, the ice cream sales tend to increase. You know this, that in summers, usually the ice cream sales tend to increase. Then come the income. People with higher incomes tend to spend more on ice cream. That is also, another important factor, and it's very easy to understand that people with higher incomes tend to spend more, right? Now comes the interaction effect. So here in the main effects, we have seen the individual impact of temperature and income, and now we are going to see the multiplier effect, right? Or you can say the interaction effect. The effect of temperature on ice cream sales might be stronger for people with higher incomes. This is very easy to understand. For example, a wealthy person might buy more ice cream on a hot day than a poorer person, right? This is very easy to understand. So wherever there is this kind of relationship and your objective needs that you should consider these kind of relationships, or you can say these kind of multiplier effects or the interaction effects, then in that case, you need to understand the interaction effect and you need to decide that yes, you have to, just understand the interaction effect and you have to consider the interaction effect while preparing your machine learning model. So how to model interaction terms, right? What kind of equation I need to consider when we are talking about the interaction terms. So ice cream sales is equal to beta 0 plus beta 1 into temperature plus beta 2 into income plus beta 3 into temperature into income plus epsilon, which is basically the intercept on the y-axis, right? So in a statistical model, we can represent this way. We are understanding the ice cream sales here. So ice cream sales is a dependent variable, right? And the temperature, income, these two are the independent variables. So this term like beta 3 into temperature into income is the interaction term, right? This is the interaction term, right? The second last term. This is the interaction term because here we are multiplying. Here we are understanding there is a correlation between the two features, temperature and income, and their multiplier effect is going to impact the ice cream sales, right? So that must need to be considered. So here B0 or the beta 0, you can say, let's say beta 0. So beta 0 is the base cell, right? Like without in considering any temperature or income, at least this sale or this amount of sale always happens. That is the baseline sale. Then comes the beta 1 into temperature. So beta 1 is the change in value, beta 1 is the change in value when the temperature increases or decreases. Similarly, beta 2 is the change in value when the income increases or decreases. Basically, when the income increases, then what should be the value of beta 2? So that ice cream sale can fit into that variable, into that value which we know, right? Which we have seen in our test data. Similarly, this will be beta 3, where the multiplier impact of temperature and income impacts the ice cream sale. So all these things we have to consider, and these values are calculated based on this, using some of these statistical models. So those statistical models are always available in the Python library, and we are going to discuss in the coming videos. But yeah, these things, decides like how you can decide it, how you can decide, or you can prepare a model for the prediction where a number of factors are involved, and where some of the factors have a multiplier impact on each other, right? There is an interaction effect. So if there is another variable here, it may be that you have to multiply that variable as well here, like temperature into income into that variable. But this is not always the case. You have to find out the true relationship where the interaction or the dependency can be defined. It's not like if you talk about temperature, income, and now you talk about your age, right? In case of age, only the income and the age, these two are the interaction terms, right? Like if your age, whatever your age is, you may be a child, but yeah, if you are poor, then in that case maybe a poor person will not go for buying more ice cream. So in case you have consider one more term like age, right? Then in that case, the multiplier effect will be defined on the income and age. So you need to multiply income and age. It's not like if you increase one term, then you simply multiply temperature into income into age. You cannot do that, right? Although that multiplier term can also be important for you based on the scenario. Like here, it seems important, but yeah, the impact of income and age, that plays another crucial role, and that plays a bigger role, right? So that interaction term could be considered as a separate term as well, right? So this is how the interaction terms are defined. Okay, so this is the basic equation. So we have lot of uh, libraries available. There is one library available in Python. Using that library, we can simply define this, right? We can simply find this. So you don't need to write the logic for it. You just need to understand that what we do, right? Rest of the things, whatever you have understood, these kind of calculations, calculation of beta 0, beta 1, beta 2, beta 3, all these calculations, these are done by the function in that library, in that Python library. So with this, I would like to say that you must have understood it. If no, then in that case you can put a comment. And in the next video, we are going to see a mathematical example on the interaction term. So till then, have a nice day.